Today's lesson, we're going to talk about probability and some of their definitions. We have random experiments, trials, outcomes, sample space, events, certain events, impossible event, disjoint event, probability of the event, relative frequency probabilities, and so on. And their definitions are written right here, and maybe you can pause this video and read them and see what those definition is. But we will probably understand better when we're actually working on the problems. First example is asking us to find or give the sample space for this random experiment. The first experiment is rolling a dice. So when you roll dice, you have 6 size dice. So you can have 1, 2, 3, 4, 5, 6. So that's the outcomes you can have. And we call that sample space. What about B? You're rolling a dice, but at the same time, because it's a N, tossing a coin. So in that case, 2 things is happening. So for the coins, you could have head, but when coin have head, you could have dice 1 or 2. So this is what you can happen with head. 3, head with 4, head with 5, head with 6. But then when you have a tail, you could also have tail with number 1 on a dice, or tail with 2, tail with 3, tail with 4, tail with 5, and 6. So this is the outcome they can have. We call this is sample space. What about C? It's a experiment consisting of studying the number of boys and girls in family with exactly 3 children. Having 3 children, one sample space can be having all 3 boys, or first 2 boy and the last 1 girl. But having a 1 girl, you could have girl in the middle, or girl first and 2 boy, right? So this is 3 sample of having 2 boys and girl. But then you can also have 2 girls and boy, and there will be another 3 samples of it. Boy, girl, girl, or having a girl first and then boy, or boy in the middle. So we have 3 examples where you have 2 boy, 3 examples where you have 2 girls. So now you could have all girl, right? 3 girl. And that's going to be the sample space of having 3 children. Now we're going to look at finding probabilities. So you're rolling a dice, and what's the probability of A event? The die shows A. That's going to be, you have total of 6 outcomes, remember? getting either 1, 2, 3, 4, 5, 6, right? 6 total outcomes. Over getting a 4 is going to be just 1 times. So your event is going to be 1 out of 6 event. The second one is asking, the number shows is less than 10. Less than 10, remember the total outcome is 1 through 6. None of the number is higher than 10. All of them is 6. So if you wanted to write this as the probability, your total outcome again is 6 because it's 1 through 6. And all of those 6 number is less than 6. So it gives you 6 out of 6, which is going to be 1. So when you're looking at the probabilities, 1 is going to be highest and 0 will be the smallest in the probabilities. Where when you do the percentage, 100 is highest and 0 is the lowest, right? The third one is asking when it shows 7. So showing a 7, there is no number 7 on a die, 6 size dice, right? So out of total of 6, you have 0, 7. This gives you 0, which is empty set. Example 3 is asking, sample space S is given as 1 through 18. What is the event E, which is subset of the sample space, that corresponds to each of the following outcomes? Indicate whether the event is the sample event or a compound event. So the first event is outcome is a prime numbers. So your prime number, let me list the prime number as your event E. Prime numbers start from 2 because prime number have to have 2 factor only, itself and 1. So 1 cannot be included. So start with 2, 3, 5, 7, 11, 13, and 17. Out of this number, right? So this is going to be prime number from the sample space, and we're going to call that as event E. And they wanted to know if this is going to be sample event or compound event. Well, this is going to be compound event since event has more than one element. Okay. What about the second case? Second case is asking the outcome is square of 4. Square of 4, 4 is not included. 4 square, when we do that, this gives you 16. So this time you have only one event out of the sample space. So this one is called simple event since you only have one element. Example 4 is asking consider experimenting rolling or 2 dice. Wrong spelling, right? What is the event that corresponds to each of the following outcome? The first outcome is a sum of 7 turns up, right? So in order to find all this answer, before that, I wanted to know what's the sample space we're going to have. We need to know sample space, number of the sample space, in order to find the probability, right? Because that always goes on the denominator. So what happened when you're rolling out 2 dice? Let me see. So it could have 1, 1. So first die 1, second die 1. If first die is 1, it could be 2 on the second dice, or 3, 4, 5, and 6. And same thing will happen when first die is 2, right? All the way to 6. It will be same thing if first die is 3, right? And all the way to when first die is 6. So when you're counting this, you're going to have 6 side, 6 down, which is going to be 6 times 6. So your outcome is going to be 36 total outcomes. And then once we understand that, let's see what the first one is asking. First one is asking sum of 7 turns up. Sum means when you're adding these two numbers. So adding this number 7 is going to be 1 plus 1 is not 7. So it had to be 1 and 6. This is 7, right? Or 2 and 5 will be 7. So let me write that down. On A, you could have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So that's going to be outcome of sum of 7, right? So how many of them? You have 6. What's the total outcome? 36. When you reduce, it will be 1 over 6. So that's going to be 1 over 6 event. What about B? B is asking sum of 11 turn up. 11 is going to be only when you have 5 and 6. 6 and 5 and 5 and 6. So it will be 2 out of 36, which reduced to be 1 over 18 event. C is asking less than 4. Less than 4 means 1, 2, 3 happening. That's less than 4. But none of them is going to be added to be 1 because the smallest number when you add 1 and 1 is going to be 2. So 1 is excluded. So how many you have 2? That will be just 1 and 1. And 3 is going to be either 1, 2 or 2, 1. So you have 3 over 36 reduced to be 1 over 12 events or probabilities. The last one is asking sum of 12. 12 is just one event, which is 6 and 6. So that will be 1 over 36 event. Example 5. Tossing a nickel and a dime. So you're tossing 2 coins. Again, we wanted to find the total outcome first. So outcome. Let's say total outcomes. We could have either tail and tail, or tail and head, or head and tail, and head and head. So when you're tossing 2 coins, you could have these 4 total outcomes. With these 4 total outcomes, the first one is asking, what's the probability of getting 1 head? This one had 1 head, this one had 1 head. No head, 2 head. So it will be 2 out of 4, which is 1/2 or 0.5 probabilities. The second one is asking probability of getting at least 1 head. Least 1 head is including 1 head and 2 head, which is going to be this 3. So it will be 3 out of 4 or 0.75 probabilities, right? The third one is asking of getting at least one head or at least one tail. Least one head, all three of them have least one head. Least one head, so it counts two head also. Or least one tail. Well, this one have two tail. So all this case have either one head or one tail. Least, right? So 4 out of 4, all of them happening. So you're going to have 4 out of 4, which is 1. So probability of 1 means 100%, right? 100%. It will have least one head and least one tail. The fourth one is asking for getting 3 head. Well, you're only tossing 2 coins. So having 3 head is impossible, right? So that's going to be 0 probabilities. Example 6 is asking for rolling 2 dice. We did that in example 4, which outcome was 36, right? Total outcome. So total outcome of rolling 2 dice is going to be 36 outcome. Remember that. And A is asking sum of 7. B is asking sum of 11. C is asking less than 4. And D is asking for sum of 12. This is going to be, again, very similar to example 4. So look over it, and I'm going to write the solution down for you. So pause and solve the problems. If you need help, look over example 4 and check your solutions to see if you get them right. There is solutions. And now let's look at example 7. Example 7 is asking, drawing 5 cards from a 52 card deck without replacements, what is the probability of getting 5 spades? So you're going to find probability of event, which is going to be number of event over number of the sample space, right? This one, order is not matter, getting 5 spades, right? So we can use commutative properties. Out of 13, picking 5. Because each shape you have 13 cards, right? Out of 13 spades, picking 5 over out of 52, picking 5. If you actually do the math, for the numerator, you get 1,287. Denominator, it's a little larger, obviously. And when you divide that, it gives you very small number. So that's the probability of getting 5, all 5 card space when you're picking 5 cards out of 52. Example 8 is asking, a board of reason of university is made up of 12 men and 16 women. If a committee of 6 is chosen at random, what is the probability that it will contain 3 men and 3 women? So because it's mixture of many options, let's see. Number of space, sample, the total we're looking for is out of 28 because 12 plus 16. Out of trying to pick 6 of them, right? And number of event, in this case, we have 3 men and 3 women. 3 men and 3 women means out of 12 men, you're picking 3. And out of 16 women, you're picking 3. And if you wanted to write that in a probability format, you will have number of event over number of sample size. So sample size we already know, right? That's going to be 28. You're picking 6. But in order to get 3 men's, you're going to do 12 out of 3 times woman. 3 women will be 16 out of 3. So when you do all that on the calculator, you should get something close to 0.327. So this is your probability. And they did ask for probability. But if they ask for percent, all you need to do is multiply by 100, which is going to give you 32.7%, right? So it depends on how they are asking. If they're asking for probability, decimal forms. Percent, it will be percent form. Example 9, which is the last one from this section, is asking, single card is drawn at random from the standard deck, which is 52 cards. Find the probability of each. So don't forget, we're looking for probability, not the percent. So it should be the decimal form or fractions. So first one is asking probability of drawing on ace. How many ace? So you have 4 different shapes for standard deck of card, and each shape you have 1 ace. So you have 4 out of total 52, 4 ace card out of 52 cards. When you reduce that, it gives you 1 over 13 probabilities. Second one is asking drawing of face card. What's the face card? Face card is king, queen, and jack. Since you have 4 different shapes for all king, queen, and jack, 4 times 3 is 12. So you have 12 of the face card over 52. Again, what's the face card? Face card is going to be king, queen, and jack. And when you reduce this, it will give you 3 over 13. The third one is asking drawing a space. Remember, each shape have 13 cards. So you have 13 out of 52, which gives you 1/4. Another way to looking at it, remember you had 4 different shapes, so it will be 1 out of 4, right? Probability. The last one is asking drawing a spade or a heart. So how many spades we have? 13. Heart also 13. Or means you're adding those. So 13 plus 13, you get 26. So it will be 26 out of 52, which is going to be half of it. So this is how you're going to find probabilities, simple probability from some of the word problems.